All right, we're going to go over a couple things. We're starting our last topic, which is Module 5, Topic 1 on volume. We just finished up on circumference and area of a circle. We're going to start with volume in a general sense that should be familiar, and then get to volume of a cylinder. Okay, so this says the volume is the amount of space that an object occupies. It says the units of volume are cubed. So when you're looking for area, it's typically, right, you're asking yourself how many squares fit in that area. So like let's say this is a meter and a meter, this is meter squared to the second power. But for volume, you're asking yourself is how many cubes, right? We could say 1 meter by 1 meter by 1 meter. So this is the one, you would read this as cubic meter. So like I'll put that over here. So cubic, for this first one is a cubic centimeter. So it's weird because, whoops, because you actually say the cube first and then the unit. So this is 1 cubic centimeter, 1 cubic inch, 1 cubic meter, right, so on. Anyways, so actually that goes right over here. So in this cloud, this is how to say this. This is one. You could read this as 1 foot cubed, but that's a weird way to say. Like if I were to describe this, this is 1 foot cubed. No, this is 1 cubic foot. But you could say one foot cubed. But really, what I see here is a cube, right? 1 cubic foot. Now, starting out, the volume of a prism. A prism it can be any shape. Pretty much how you describe a prism. It's you have any type of shape. I'm gonna take a rectangle, or visually this might look like more of a parallelogram. If I take that and I copy it, and you connect corresponding parts, this is what a prism is. So this is what we call as a rectangular prism. Let me draw some type of triangle and then copy it over here. Right, this would be a triangular prism. Let's put it, this is a rectangular prism. Right, different than a pyramid. A pyramid, it meets at a point, at an apex. Anyways, so to find the volume of a prism, it's L times W times H, which is length times width times height. Pretty much you see 3 numbers and then you multiply those 3 numbers together and you get the volume. Okay, so we'll take this example, a cube. A cube is where all sides are equal or congruent. There should be a mark right here. So we're saying that the width of this is 6 meters, the height of this is 6 meters, and maybe the length of this is 6 meters. Okay, so we would put V equal to L times W times H. Normally for my L's, I put like a cursive L so you don't confuse that with a 1. So length times width times height. And we're going to put this as 6M times 6M times 6M. You could just put 6 times 6 times 6, but the reason I wanted to write the M here is because if we rearrange this, really what this is 6 times 6 times 6. And the M's are all together, M times M times M. I don't know what this is going to be, but we know that this will be M cubed because M cubed means M times M times M. So this is 1 cubic meter, but how many cubic meters do we have if we multiply 6 times 6 times 6? So 6 times 6 times 6. 6 times 6 is 36, and to get our final answer, we're going to multiply 36 times 6, so 30, whoops. I'll put a 36 times 6. 6 times 6 is 36. 6 times 3 is 18. 18 plus 3 is 21. So V equal to 216 cubic meters. So the way I want you to think about this is if this is 6, let me kind of draw some lines here. So this is 6 meters here. Maybe that's the 3. So there's 3 right here. So this is 1, 2, 3, 4, 5, 6. I'm going to take this one right here and make a cube that's that length. So this is going to be something like this. So what our answer represents is if we have a cube like this, I guess I can shade it here. That's how much we'll talk about. We'll say paint. That's how much paint is needed to fill this up. There are 216 of these that I would take individually, put them into this bigger shape to completely encapsulate that object. Okay, so that's what it's asking. So when you're looking at area, it's how much paint is needed to paint a surface, where volume is how much paint is needed to fill in that surface. So think about that. All right, let's go to, we worked with the cube where all sides are congruent. Now a rectangular prism. So the length times width times height, it actually doesn't matter what you say is L or the width or the height, because if you turn it, it could be something else. But I'll say that this is W, that's the width, this is the length, and this is the height. So let's plug that into the formula. So L is 8. Yeah, so the order of this does not matter. And just notice with this, I'm not putting yards anywhere, but it is important that you put cubic yards as your final answer. So let's multiply 8 times 6 is 48, and then I got to multiply that with 3. This is 24. That's a 12 plus 2, which is 14, so 144. So V equal to 144 cubic yards. Or you could say yards cubed. Okay, it's just weird because it's like saying like $1 versus $1. There's like a normal way of saying it, but we know what you mean. And for this, what I'm gonna do, I'm gonna do a slightly different problem that I want to include here. I like to include a triangular prism. So it's V equal to, and the way I want you to think about this, right? It's not just you multiply 3 numbers. It's this. This capital B represents base, but it is the area of the base figure. So what I mean by this is for a rectangle, it's a rectangular prism, it's a rectangle. Triangular prism, it's a triangle. So I'm gonna draw a right triangle. Let's do it like this. And I'm gonna copy that same exact shape, hopefully. And then let's copy, or let's connect corresponding parts. So the area of a triangle, if you don't know, it is half of the base times height of the triangle. And then we're gonna multiply the height of the entire triangular prism. So let's say that the base of this is 2, the height of this is 3 of the triangle, and the height of this entire thing is 4. We'll say that this is in terms of inches. Okay, so plugging this in for the triangle, this will be 1/2 2 times 3. I'll just put this all over 2 times 4. Now here 2 times 3 is 6. 6 divided by 2 is 3. So over there, our final answer is just 3 times 4, and that is 12 cubic inches as our final answer for this triangular prism. Okay, so really anything can be expressed as this, as the volume is whatever the base figure is, so like this, and then multiplied by the height. So where's a good object? I'm going to use this one right here. Let's use this object here. I'm going to draw the base figure, which is a rectangle, or it should be a square, but visually it looks like a rectangle. I want you to think about this as like a square of cheese. So like those singles cheese slices. You want to think of a singular slice of cheese as that's finding the area. But really what you're doing from there is when you stack up all these cheeses together, it creates this cube. So really, like this, you could think of this as a triangle, or I don't know, maybe this is a nacho. If you stack all these nachos together, right, it gives you a triangular prism. So we're gonna get to cylinder here, and I want you to keep that idea of what is it represented as the base times height. Okay. Now there might be some things that are familiar with this, so I'd like for you to now go to a separate page, which is the volume of a cylinder, slightly different. So we have really three examples, but really we're kind of focused on this first example. But this is the formula for the volume of a cylinder. It's V equal to pi r squared times h. I'm going to put, let's annotate here, put a dot right here, and I'm going to annotate this part. You can circle this. That should be familiar. So ask yourself, where have you seen this formula? This is the area of a circle. Okay. So we're gonna X-ray this cylinder here. Let's draw this. I'll put a center. Maybe we'll draw a radius. You're welcome to color this in. So the way I want you to think about this is this is a circle, or maybe think of this as like a baloney. It should be more pink, I guess. But if you were to stack up like a bunch of balonies together, or a bunch of maybe Oreos or something circular, you would get this, what we call as a cylindrical object, or just a cylinder, right? So the way that we can think about this, it's a circle times here is how many circles, or how many circles are kind of stacked on top of each other. And the important things that you're going to need here is the radius and the height. So those are the only two things that are really important within a cylinder, the only variables that you're going to need. Okay. And essentially this just becomes, right, plug into the formula. So let's use this right here, V equal to pi r squared times h. And I'll put a dot right there to separate the circle with the height. So V is going to be equal to pi, the radius is 6 feet. We'll just put, well, I'll put 6 ft. We don't really deal with our units, but we'll deal with it right now. And then our height is 3 feet. Okay. Now we're going to take this away and this away, because, well, this will be feet squared times feet is feet to the third power, or cubic feet. So in this, the order that I want you to go through is order of operations. You need to square the number first. So 6 squared is 6 times 6, which is 36. I'll put that in front. I'll put pi right after that, and I'll keep this 3 at the end. We're ignoring the feet for now. We know that our answer will be cubic feet. Now, whenever you have numbers that are all kind of joined, it means that they're multiplying. So we're going to multiply 36 times 3. 18, 9, 10. This is volume is equal to 108 pi cubic feet. Now, you might see it where if the direction doesn't say multiply by pi or use 3.14, this could be your final answer. Or if it does say multiply by pi, you're going to multiply by 3.14. So 108 times 3.14, let's use our calculator there. Times 3.14. Okay, we get this number 339 and 1200, so 33912. And this is cubic feet. So I saw quite a bit of students on the assignment for circle not label it. If you were to put that this is just 339 and 1200ths and no unit, or even if you just put foot or foot squared, or sorry, square foot, that's incorrect. It's got to be cubic feet. So that's how many 339 approximately of these would fit into this bigger object. Okay. Now, for the most part, this is what is required when you're finding the volume. But there are some times where you're going to be given information and you have to find some other piece of information that we don't know. So let's do that right now. For this first one, it says determine the height. So we don't know how high the cylinder is. We do know that the radius is 2 inches and that the volume of this is 28 pi. So how do we go about this? Whenever you start a problem like this, I always want you to rewrite the formula and then plug in where we know. So we know that the volume is 28 pi. So this, they didn't multiply by 3.14. So let's keep that, 28 pi. Actually, I'll draw a line down the equal sign so we're more organized. We'll keep pi here. We do know what the radius is, which is 2 inches. And we don't know what the height is, so we need to solve for that. So when you're given something like this, let's simplify each side. The left side, 28 pi, can't be simplified, but the right side can. 2 squared is 4. So let's rewrite this. Typically, you put your coefficient in front, so 4 pi. And I'll put times h. I mean, you could put a dot here too. They're all multiplying. And then what's different about this is I'm going to have to move stuff away from our unknown value, which is our height. So I'm going to get rid of 4. Now 4 is multiplying, so I would have to divide both sides by 4. But I'm going to try to be efficient here also. Pi is also just a number. It may seem it is a variable in that it represents a value, but it's not a variable where in the sense that it's not an unknown value. We know that that's 3.14. So pi is just a number. So instead of just dividing by 4, I'm actually going to divide both sides by 4 pi. And we'll see in a second why we're doing that, making our life a little bit easier here. So when we do this, the 4's go away. That equals 1. Pi goes away. And then on the left side, pi also goes away here. And we want that because really what we're left with is 28 divided by 4. That goes into evenly. 4 can go into 28 7 times. So that is our answer. So we're going to say that the height of this, our units is, so we're going to say the height is 7 inches, or you could put the like quotation symbol, double line. All right, good. So this, like, was this any different than this? Sure, where we don't have to move anything across the equal sign, but we had to undo some operations, so that's why we had to divide. Okay, let's move on to the radius. And for this, we do not have an image to look at. I mean, that's fine, but we just have to be careful with this. If you want, you can draw an image. I mean, we can draw an image here. Not sure how this would look like, but let's say something like this. Okay, we know that the height is 9 meters, so I'll put 9m. We do not know what the radius is, so I'll just put r. Let's rewrite the formula. Okay, we know that the volume is 225 pi cubic meters. So I'll write that on the left side. That's replacing V. We don't know what R is, so I'm going to keep that. And times, we'll put 9 for H because it's 9 meters. We can simplify things, but really, I can't really simplify anything, but I can rewrite this. I'm going to put this 9 all the way to the front because that's what we typically do. Always put our coefficient in front. I'm going to put 9 pi r squared. And then with this, I can't simplify anything, but I can divide out. I can divide by this 9 since it's multiplying. Divide both sides by 9. But again, we want to be efficient, so I'm going to divide by pi as well. So 9 divided by 9 is 1. Pi divided by pi is 1, as well as over here. So really what we have here is 225 divided by 9 equal to r squared. We can't get rid of the square yet, so let's divide out 225 divided by 9. That is 25. So if you have 9 equal to $2.25. And then at this step, it's been a while, but working with Pythagorean theorem, we know that if we see some type of square, how to undo that is we can take the square root of both sides. Square root of 25 is a nice number. It is 5. Our units were in meters, so 5 meters is equal to the radius. So the radius right here, we're going to say is 5 meters. So it's somewhat to scale. Okay. All right, we're going to end it there. We are going to get back to working out of the book on cylinder, but I wanted to include this example because I think this is a lot more organized where you have specific examples to refer to, right? Find the volume, find the height, find the radius, and we also have the formula as well. Okay, anyways, we'll call it there.